Hey folks, today we are going to be talking about electromagnets, and you can actually see electromagnet in action here in this little video. You can see that it is a magnet that you can turn on and off. So we are going to go ahead and see how that works. All right, let's go ahead and start off by setting up our notes. Your essential question for today is, how does an electromagnet work? And then your four guiding questions are, how can you control the magnetic field of a wire? What is a solenoid? What is an electromagnet? And how do you change the strength of an electromagnet? Go ahead and pause the video and set up your notes, and then we'll get started. Our learning target for today is, I can build and explain how an electromagnet works. Alright folks, go ahead and pause this video and play the video that comes up in your Nearpod. This shows a very practical use of an electromagnet at a junkyard and is a pretty cool video. So go ahead and pause this video, play the Nearpod video, and then come back to this video. Alright, so as you saw in that video, by being able to turn a magnet on and off, they can do some pretty interesting things with it. So we're going to talk about how that works. So let's go ahead and back up and talk about what we already know about electricity and magnetism. So as we learned in our last lecture, moving electric charges create a magnetic field. And we saw that when we had the loop of wire that was connected to a battery, and then we placed a magnet above and below the wire to see the magnetic field. These fields move in circles around a wire, right-hand rule, and they are relatively weak. However, if you combine magnetic fields, that makes them stronger. We know about that through the process of which a material is magnetized, and the same thing is true here. And so, the first thing that we should know is that if you loop a wire together so that the magnetic fields overlap, the magnetic fields will combine and will create a stronger magnetic field. So, what happens if you loop a wire over and over and over again? Well, the strength of the magnetic field would continue to grow with each loop because you're aligning more and more magnetic fields. This is what is called a solenoid. It is a coil of current-carrying wire that produces a magnetic field. So you can see right here in this diagram, we have a solenoid that is represented in this kind of copper wire. You can see that it's going all around here. And that the magnetic field, there are so many repeating magnetic fields that it ends up creating a much stronger magnetic field. And when what you can see here is that ultimately we have two poles, and the magnetic field resembles that of a bar magnet. So a solenoid acts like a bar magnet that you can turn on and off. Go ahead and make sure that you have a version of this diagram that I've laid out here of what a solenoid is and its magnetic field in your notes. So, alrighty. Now, if you place a ferromagnetic material such as an iron rod or a nail into a solenoid, then the strength of the magnetic field increases. This is because the magnetic field of the solenoid causes the iron rod to become magnetic. It aligns the magnetic domains in that ferromagnetic material. Thus, you have even more magnetic fields aligned and creating an even stronger magnet. And this is what we call an electromagnet. An electromagnet is a solenoid with a ferromagnetic core. And so you can actually see an example of a very simple electromagnet here. You have a battery, that's the source of your current. You have a wire coming out and creating a solenoid, that coil of wire, and coming back to create a circuit with the battery. But then into that coil of wire, we place a nail, and that creates an electromagnet. So once again, if you turn off the current, the magnet goes away. So a nice little practical use there. So the strength of an electromagnet depends on three main variables. The first is going to be the current in the solenoid. The second is going to be the number of loops in the solenoid coil. And number three is the type of ferromagnetic core. So with the current, stronger magnetic field. If you have a larger battery, you're going to have more current moving through there, and it will create a stronger magnetic field. Loops. If you have more loops, you have a stronger magnetic field because you have more alignment of more magnetic fields. And so once again, that's going to result in a stronger magnetic field. And finally, a core that is easily magnetized, such as iron, is going to create a stronger magnetic field as well. So let's go ahead and take a look at how all of these different parts of the electromagnet, from a solenoid up to a full-scale electromagnet, and how the different variables affect electromagnet strength. Alright folks, so what we have here is a solenoid. It's just a coil of wire, and we're going to show how electricity and magnetism are related. So I'm going to go ahead and create a loop or a circuit with this by touching it to a battery, and you can see that it affects the compass here when it's on, but it's not powerful enough to pick up a paper clip. Now, if I go ahead and take a iron core, in this case a nail, and I slide it through there, and now I touch it to here, now it is going to be able to pick up a paper clip because the iron core increases the strength and creates an electromagnet. All right, now what we're going to do is increase the current in our electromagnet by using a larger battery. So it's the same setup we had before, and now I'm just gonna go ahead and send current through here, and you can see now with more current, it picks up more paper clips. All right, folks, so last thing I did here now is I've created more loops on my solenoid around my iron core to make an even stronger electromagnet using the same battery as before. So go ahead and create the circuit, and what you will notice is now I can pick up a bunch of paper clips at once because my electromagnet is even more powerful than it was before. Alrighty folks, welcome back. Let's go ahead and take a 4-question ungraded quiz to see where we're at. Go ahead and pause the video, take the quiz, and then come back to check your answers. Alright, which of the following will increase the strength of a magnetic field of a wire carrying a current? Alright, so we look at all of these options, and you could increase the current. We know that that is going to increase the strength. And then if you make a loop with the wire, you'll cause the magnetic fields to align, thus creating a stronger magnetic field. A coil of current-carrying wire that produces a magnetic field is a solenoid. A solenoid with a ferromagnetic core is an electromagnet. Which of the following affects the strength of an electromagnet? The number of loops in the solenoid is going to affect it. The amount of current is going to affect it, and the type of metal used in the core is also going to affect it. So let's see how we did here. Bada bing, bada boom. If you answered like that, you got 4 out of 4. All right, folks, if you have any questions about electromagnets, please add them to the discussion section, and I will make sure that I answer any questions that you do have. Have a great day, folks.